I welcome you all and I request learners, students, practicing, those who have registered with this course and attending this session today to post your question in the chat box so that we can discuss those questions sequentially. This course, Thermal Engineering Basic and Applied, is an important course for the undergraduate students of mechanical engineering, electrical engineering, aerospace engineering, chemical engineering, and power engineering. So in this course, several applied systems, applied components have been described, have been discussed, and basics of thermodynamics are also discussed in this course. So those who are listening to this session and those who have joined this session, I shall request to you all to post your question in the chat box so that we can start our discussion on those questions. I request students, learners of this particular course who have enrolled this course and joined this session to post your question if you have any in the chat box, or also you can join this session so that we can directly interact with you all to clear doubts if you have any based on the modules that you have completed by this time. The course Thermal Engineering Basic and Applied is an elective, it is an important core course for the students specializing in mechanical engineering, electrical engineering, aerospace engineering, chemical engineering, and there are many other branches, and students of those branches also consider this course as an elective course. So this course is an important core course to the students of mechanical engineering, chemical engineering, and aerospace engineering. In this course, we have discussed, thermodynamics, rather basic laws of thermodynamics. Then we have discussed several components or applied components, starting from steam power plants, steam power cycles. Then we have discussed about internal combustion engine. We have discussed several components of steam power plant. We have also discussed about refrigeration cycle, and we have also discussed gas turbine unit and gas turbine cycle. So students, learner who have enrolled this course and who have registered with this course, I shall request you all to post your question in the chat box if you have any, so that we can take those questions for discussion now. If anyone has joined this session, shall request them to interact with me if they need any assistance, help, and if they have any doubt to be cleared in today's session. I request students, learners, practicing engineers, and all registered candidates of this particular course to post your question either in the chat box, or you also can have direct interaction with me in this session. This session is kept only for direct interaction with the learners of this course. This session is limited to only 1 hour, so I shall request you all to post your question, to raise your questions if you have any, so that we can start our discussion now. In this course, we have discussed about steam power plant, considering the basic cycles used to describe the processes of a steam power plant. Thereafter, we have discussed several components like boilers, turbines, cooling towers, which are the main components of the steam power plant. We have solved several numerical problems to illustrate the conceptual part of this particular course. I mean, there are several modules of this course. For each and every module, first we have discussed the theoretical part, the conceptual part. Thereafter, we have solved a few numerical problems, essentially to illustrate the conceptual part. We have also discussed about internal combustion engine. We have also discussed gas turbine cycle, and most importantly, refrigeration cycle. These components are very important and useful for the design of practical system. So the content of all these modules are very important to design, to understand several processes in several practical or applied systems, and this understanding will help you to design several systems as well. So I would like to request the registered participants of this course to come forward to raise your question in the chat box, or if you'd like to have direct interaction with me, you are most welcome to this session. This session is limited to only 1 hour. So I would request you all to start posting your question in the chat box, or if you have joined this session, then please start interacting with me. In this course, we have also discussed basic thermodynamic laws, which are important to understand several processes of different applied systems. Combined first and second law of thermodynamics is very important to understand the interaction of energy, either in terms of heat or work, of several processes. Those are there in steam power plant and also refrigeration unit. So also we have discussed about internal combustion engine, processes of several processes of internal combustion engine. We have discussed that cycles which are used to describe the processes of an internal combustion engine are not the thermodynamic cycles, because in these cycles, composition as well as mass of the working substance is not getting conserved. So at the end of the cycle, mass as well as composition of the working substance change, and hence these cycles cannot be called as the thermodynamic cycles. We call these cycles as the mechanical cycles, and considering different cycles, we have discussed processes, or we have depicted several processes in thermodynamic ordinate diagram, and then we have tried to quantify thermal efficiency of all these applied units or systems. As I said, in this course we have also discussed gas turbine cycle, and with the discussion of gas turbine cycle, we could quantify thermal efficiency of gas turbine cycle as well. We have also discussed basic laws of thermodynamics, which are very, very important to understand the processes of any applied unit. Most importantly, all the components of any applied unit, all the components of any applied unit need to interact with heat or work. So to understand whether any particular component or device is a heat interacting device or work interacting device, laws of thermodynamics are very important. We have recapitulated our understanding of thermodynamics in the beginning of this course. I would like to request you, if you have any question, to post your question in the chat box so that we can take those questions now for the discussion. So I can see one question. If boiler pressure is maximum in modified Rankine, the Rankine spelling is not correct. So as Rankine cycle is as compared to simple Rankine cycle, then what will occur? Then what will occur effect in steam power plant? I didn't get your question properly, but what I can understand from your question is that if boiler pressure is maximum in modified Rankine cycle as compared to simple Rankine cycle, see, probably we have discussed about several modifications of simple Rankine cycle towards the enhancement of thermal efficiency. One modification could be to increase the boiler pressure. Certainly, if we increase the boiler pressure, try to understand, then what will happen when the steam will expand in the turbine. Then we assume that the expansion of steam inside the turbine is isentropic expansion. So certainly at the exit of the turbine, if you just try to recall, with increased boiler pressure, we'll be having some moisture content or quality of the steam will be deteriorated or degraded if we increase the boiler pressure compared to the simple Rankine cycle. Though it would be possible to increase the work output by increasing the area in the TS plane around the process curve or above the process curve, but with increasing boiler pressure, the expansion process of the steam in the inside the turbine following isentropic process will ensure poor quality of the steam at the exit. If it is so, then that moisture content in the steam at the exit of the turbine may lead to some problematic issues with the erosion of the turbine blade. So that will have some detrimental impact on the turbine blade life. I should say corrosion of the turbine blade would be more in case if we increase the boiler pressure to get more work output, as because the quality of the steam at the exit of the turbine will reduce. So if we increase the boiler pressure or if we keep the boiler pressure maximum in modified Rankine cycle, then certainly we can increase the work output. You can understand by plotting the area under the process line in TS plane. But what will happen, the quality of steam at the exit of the turbine will be reduced or will decrease rather. So the poorer quality will have some detrimental impact on the life of turbine blade, because turbine blade, corrosion can start. So this is one of the problematic issues with increasing boiler pressure in a steam power cycle. Okay, so I have discussed several modifications of increasing the efficiency of steam power plant or following simple Rankine cycle. So the modifications are, if I can recall correctly, increasing boiler pressure, then lowering the condenser pressure, or superheating the steam. So superheating the steam could be a better avenue to increase the efficiency of the simple Rankine cycle, because in case we want to operate boiler at a relatively higher pressure, certainly we can maximize or we can increase the amount of work done by the turbine, but we can increase the work output essentially at the cost of the quality of the steam at the exit, or at the cost of the steam quality at the turbine exit. So this is what is not suggested even. And even if we try to increase, or even if we try to decrease the condenser pressure, so you know that perhaps we can increase the work output, but the issue would be condensers are operated at a pressure which is less than atmospheric pressure. So if we reduce the pressure or at which condenser will be operating, then leakage of air into the condenser will be more. So that air leakage into the condenser will create some problematic issues related to degradation of heat transfer, and also that typically we need to supply coolant through the condenser to take away a certain amount of heat. So if we reduce the pressure inside the condenser, that also will have coolant that we are going to circulate. So essentially coolant is water which is taken from nearby lake or river or any other water body, so which is available at the atmospheric pressure. So if we try to reduce the condenser pressure, I have discussed this critical part even in the class, that reduction in condenser pressure towards the improvement of efficiency of Rankine cycle is not even viable, considering two problematic issues. One is circulation of coolant, because water is available here at the atmospheric pressure. If we reduce the pressure of the condenser below the atmospheric pressure, then that heat transfer by the coolant will be affected. Second thing, leakage of air into the condenser will create a thin, air film on the condenser, pipe surface. So, coolant surface. Coolants are circulated through the tubes, while streams are allowed to pass over the tubes. So when air leakage will be there, that air will try to have a thin air film on the tube surface, so that will try to prevent direct contact of incoming steam from the turbine to the pipe surface, and hence heat transfer rate would be affected. So in this course we have discussed all these critical issues, and we have discussed several applied components, applied units, process which is needed to describe the performance of a particular component in different applied systems. We have discussed basic laws of thermodynamics in the beginning, essentially to have better understanding of the processes. Those are used to describe, applied systems or different applied systems. I would like to request registered participants of this course to raise your question in the chat box if you have any, based on the understanding of your on the subject, and you have completed a few modules by this time, and from the modules that you already have studied, had you listed down a few doubts, questions, please feel free to discuss all these questions in this forum. You all know this particular session is designed to have direct interaction with the participants of this particular course. Since this session is limited to only 1 hour, shall request all the learners of this course, if you have any questions, to post those questions in the chat box. In case you are attending this session, you are, requested to have direct interaction with me. What will state of fluid at exit of open type feed water heater? So you know that state of the fluid at the exit of open type feed water heater. Let me tell you one thing. This open type feed water heater or closed type feed water heater, these arrangements are done essentially to increase the efficiency, right? So in open type feed water heater, steam which is extracted from the turbine is allowed to mix with the feed water, essentially to increase the feed water temperature. So that it is designed accordingly so that the feed water, because the feed water will be pumped back to the boiler again. So what will happen, that this feed water temperature and pressure should be, the main idea is to increase the temperature of the feed water so that the energy that needs to be supplied to boiler for boiling can be, to some extent saved. So the state of the fluid at the exit of open type feed water heater should be, such that a pump can handle, and the temperature should be, a little higher than the normal water temperature, but it should not be very high. On the other hand, the pressure should be such that the pump can raise the pressure of that water to the boiler pressure without consuming more power or much power. So try to understand. So pumps are used to raise the pressure of the feed water. That feed water will come from open type to the boiler pressure. So then what will happen, that state of the fluid at the exit of the open type feed water heater is similar what is needed for the pump inlet. So temperature should be such that pump can handle, and at that pressure certainly it should be, saturated. So then pump can only raise the pressure of that particular liquid to the boiler pressure using the pump. So I hope you got my point. The sole idea behind this particular heat exchanger, open type feed water heater or closed type feed water heater, these two heaters are, basically heat exchangers. So in one type, mixing of two different streams are there, rather direct mixing of two different streams are there. In closed type, indirect heat transfer takes place. So in the open type feed water heater, at the exit, quality of the fluid should be such that it can be handled by the pump to raise the pressure of that, water to the boiler pressure. So our objective is to increase the temperature certainly, but if we also can increase the that would be again handled by the pump to increase the pressure to the boiler pressure level. But if we increase the temperature of that feed water before it enters into the boiler, certainly the amount of fuel that should be used to burn, the amount of energy should be supplied to boiler by burning coal, if it is a coal-fired boiler, can be reduced to some extent. Input energy can be reduced, which in turn will ensure better performance. So I request all the students who have joined this course, and in particular those who are attending this session, to raise your question in the chat box if you have any questions to be discussed in today's session. In this particular course, which is an important core course to the students of mechanical engineering, chemical engineering, aerospace engineering, power engineering, and electrical engineering, several applied components have been discussed. Numerical problems have been solved to illustrate the conceptual part of several systems, several processes. The course, is the course also. The course content also include a discussion on the basic laws of thermodynamics, because basic laws of thermodynamics and understanding on the basic laws of thermodynamics is very much essential to understand several processes in different applied units. What we need to do essentially is to measure thermal efficiency. So we need to provide some energy either in terms of heat and work, and we will be getting some work output or some energy output. So at the cost of some input energy, we will be getting some energy output, and the energy input can be in the form of heat or work, and energy output also can be in the form of heat and work. So the idea is to maximize the efficiency and the conversion of heat into work or work into heat. All these conversions need, or all these conversions are associated with some thermodynamic processes. So we have discussed all these thermodynamic processes in this course, rather in the beginning of this course, which are very important to know several systems or applied systems. And we have discussed steam power plant, we have discussed internal combustion engine, we have discussed gas power cycle, we have discussed refrigeration cycle as well. So for all these units, for all these applied systems, to understand energy interaction, laws of thermodynamics are very much needed. We have discussed this part. I request students, participants of this course to raise the question now in this session, so that we can start our discussion. Rather, we can discuss those questions systematically and sequentially. Since this session is limited to only 1 hour, I request you all to post your questions without any delay. So as I said, this course will, the course is designed, or the content of the course, the contents of the course are such that it will help you to understand several processes of different applied systems, and it also may help to design several components of different applied systems. Since this session is limited to only 1 hour, I request you all to post your questions in the chat box if you have any, so that we can take those questions for discussion henceforth. I can see that there is no more questions from the students or practicing engineers and participants of this course. I will be waiting a few more minutes in this session to discuss with you all, to discuss any doubts you have by this time already related to several components of this course, several modules of this course. I'm pretty sure that you have completed a few modules by this time. From these modules, if you have any specific questions to be discussed in this forum, feel free to raise those questions now only. In these questions, we have discussed several applied systems and components in details. We have solved several numerical problems to, illustrate the processes, the, thermodynamical concepts, and we have also discussed some practical applications of several components throughout this course. Since the course name is Thermal Engineering Basic and Applied, so in this course we have discussed many practical issues as well. So this is again, I do not know whether the question is relevant to this forum or not. I didn't discuss all the topics in this course, keeping in mind the GATE examination. So certainly several components have been discussed, numerical problems have been solved in each and every module of this course, which are relevant for this course only. I request you all to post your question in the chat box if you have any. This session is limited to only 1 hour. So if I do not receive any questions from you all, then I would like to wrap up this session for the day. I request all the registered participants of this course to post your question in the chat box, which will help me to discuss now only. Also, for this particular course, you know that you have tutorial assignments, and each and every week you have question answer session. So you can write all, if you will have any doubt, you can post your doubts in the discussion forum. TAs of this course will be able to respond to your questions. So this course, as I said we have discussed many things, starting from basic laws of thermodynamics to several processes, including the basic cycles. And then we have discussed about the design aspect of several thermal, applied thermal systems. I'm very enthusiastic about thermal engineering, being a lifelong learner and learning about power plant and administrative in policy making issues, looking for sustainable development 2070 goal. I really didn't get your question. So exactly, I really do not know what do you want to know from me through this question. So anyway, I would like to ask you and the questions that already you have asked, we have replied all the questions those you have already asked in the discussion forum. If you have any specific question to be discussed in this live session, please feel free to post your question in the chat box. Certainly, if I can understand your question, the administrative and policy making issues to be considered for a sustainable development, there are many, that nowadays the trend is to, use several, non-conventional sources of energy. And even if we need to use or to cater, to meet the demand or to cater the need of huge amount of energy, uh, you know, using non-conventional sources, whether, non-conventional sources will be able to meet the demand or not, that is also an important issue to be considered. And even if we talk about thermal power plant, certainly the most important part is this, use of state-of-the-art design of several components to maximize the efficiency. And also, that this pollution level. So I would like to request you all to post your question in the chat box if you have any in the discussion forum, so that we can take those questions for our discussion. This course is an important core course for the students of mechanical engineering, electrical engineering, chemical engineering, and power engineering. Many students do consider this course as an elective course. Keeping everything in mind, the content of the course is designed, contents of the course have been designed accordingly. In this course, we have discussed basic laws of thermodynamics. Thereafter, we have started our discussion on several applied systems. We have identified several processes. Then we have tried to quantify thermal efficiency and what are the steps or, modifications needed for any particular system towards the betterment of thermal efficiencies have also been discussed in this course. Since I'm not getting any more questions from you all in this session, I think there is no more questions to be discussed in this forum. But as I told you, in this MOOCs platform, there is a provision of posting question in the discussion forum as well. I'll be happy to discuss, or I'll be happy to give reply to all those questions even. So you will be having a few doubts, a few questions throughout this course or throughout this learning session of this course. I would request you all to post your question even in the discussion forum. We shall be happy to answer to those questions. Since there is no more questions to be discussed in this forum, I will wait for another 2 minutes before I wrap up this session for the day. Numerical problems have been solved in this course, and the problems that we have solved in this course will certainly help you to understand the underlying processes, concept behind these processes, rather concept behind those processes. I'm getting another one question. We study about financial, economic, and management issues we can learn from this course apart from engineering. You know that since this is applied thermodynamics, and certainly in this course we have discussed several applied systems, starting from steam power system, internal combustion engine, gas power cycles, refrigeration unit or cycles. So it would be a bit, difficult to discuss financial as well as managemental issues of several thermal systems in one course. Say, for example, if we talk about power plant engineering, which itself a subject, in this subject, apart from the thermodynamics and applied thermodynamics part, the financial and economics, energy economics or management part is important to be understood. So my suggestion would be that financial, economic and management issues certainly are very important for all these applied system, because energy is involved, right? We are getting some energy output at the cost of some input energy. So when there is some energy input and energy output, certainly our target should be to maximize the energy output, and even from the energy output, proper utilization of the energy should be discussed. So the questions that you have asked me, that management or economic use of energy together with financial part, that is when you design a particular system, two things are very important to know. One is the cost associated with the installation or fabrication point of view. Another part is associated with the operational of the system. So these two things should be taken into account when any thermal system or unit is designed. Thereafter, as I said you, since it is the energy which is supplied to get some energy output, so proper utilization of energy together with that energy economics or energy budget should be discussed, or efforts should be taken to understand this energy economics properly. So and that is why I'm telling it is, since in this course we have discussed a few thermal units or components, so energy economics, even management issues of all these units should be different, and management issues together with energy cost budget cannot be discussed in a generalized form. So for the example that I gave you, say for power plant engineering, there is a special chapter on energy economics, energy budget. Similarly, when we talk about internal combustion engine, when we talk about gas turbine plants, we need to discuss energy budget together with this operational part, and that is managerial part, separately. Since I am not getting any more technical questions to be discussed in this forum, I would like to wrap up the session for the day, and I would like to request you all to post your questions. Already you have, or you will face certain difficulties even in the later time. So please feel free to post all those questions in the discussion forum, and again we will be having another live session, and we can take up those questions in the next live session. So with this, I would like to stop here today. Thank you very much.